Okay, so in this lesson, you're going to learn how to graph exponential functions. All right, so let's talk about what are exponential functions. So an exponential function has this form. So you have some base raised to an exponent. And in this exponent, you see a variable. So that's what makes an exponential function. The variable is in the exponent. Now, the thing you got to remember about the base, or you got to know about the base, is that the base must be positive. So you cannot have a negative base. So the base can never be negative. Base is never negative. Is never negative. So it cannot be a negative number. So the base must be positive, and it can be any positive number except 1. So the base cannot equal 1. And as you go through this, you'll see why the base cannot be 1 and why the base cannot be negative. Because the graph of an exponential function it's a certain graph. It's a certain shape. And if it was any of these rather, it would not be that shape any longer. All right, so in order to get that shape that you're going to see, we define the base to be this. So it has to be one of these. So the base must be positive, and it cannot be 1. Okay? All right, so let's look at an example. So we're going to graph this function. So this is number 1. So let's graph this function, f of x equal 2 to the x. So we're going to look at a simpler one first. All right, now to do this, we're just going to use a t-table. And as we go through this t-table, we're going to discuss some ideas that we've learned in the past, that we had in previous lessons. All right, so remember, f of x means the same thing as y, so I'm just going to use y here. And so if I let x be 0, and it's always a good idea when graphing exponential functions, to let x be 0. Because if x is 0, remember if x is 0, you're finding the y-intercept. So you find the y-intercept. So an exponential function always has a y-intercept, so just find it. Find it first. So let x be 0. So if x is 0, we get y equals 2 to the 0 power. Well, we got to remember from a previous lesson and also from a previous course that any non-zero number raised to the 0 power is going to equal 1. So for example, remember when you have 7 squared divided by 7 squared, let's say. So remember, any number divided by itself is 1. And so what you've learned with this in a previous course was that when you divide like bases, you subtract exponents. So remember the quotient rule? So when you divide like base, subtract exponents. So we get 7 to the 2 minus 2, so the top exponent minus the exponent is in the denominator, and you get 7 to the 0. Well, if this is equal to 1, then this must also equal to 1. So when you talked about this in a previous course, you were mentioned that you were told about this idea here. All right, so that's going to be 1. So I found my y-intercept. And as we go through this, I'm going to go ahead and start plotting some points just to kind of give you an idea what it looks like as we go. So I'm going to plot the point 0, 1. So that's here. So there's a point 0, 1. All right, x is 1. I'm going to get y equals 2 to the first, which is 2. So I get 2 to the first, which is 2. So I'm going to plot the point 1, 2, which is here. If x is 2, I get y equals 2 squared, and 2 squared is 4. So I'm going to plot the point 2, 4. So I'm going to get this point here, 2, 4, which is here. If x is 3, I get y equals 2 cubed, and remember 2 cubed is 8. So I'm going to plot the point 3, 8. I'm going to plot the point 3, 8. Okay, and so I'm not going to do 4 anymore, because if I did do 4, I get y equals 2 to the 4th, which is 16, and it's not in this plane. So I just want to use points that are in here. Okay, now, before we go on, let's talk about what's happening on this side of the graph. So see what's happening on this side of the graph? So if I did 4, you'll notice that when I did 4, I get 16. If I do 5, and use your calculator if you need to. If I do 5, I get y equals 2 to the 5th, and then 2 to the 5th is 32. And so what's happening is that at each point, remember the base is 2, so 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. If I do 6, 32 times 2 is 64. But notice that the y values are doubling each time from one to the other, from one unit to the next unit. So basically it's increasing rapidly. My y values are increasing rapidly. So the graph looks like this. And do the best you can with drawing this graph, but it's increasing rapidly. Now, it's not a parabola, so don't think that this is a parabola, because it's not. All right, so don't make that misconception, since you've spent a whole chapter on graphing parabolas, several sections on graphing parabolas. So this is not a parabola. Okay, so you can see what the shape's going to look like, but it increases rapidly. All right, now if x is -1, so let's try -1. So if x is -1, I get y equals 2 to the negative first power. And you may remember from previous courses that 2 to the -1, to make this exponent positive, I'm going to take the reciprocal of the base, so it'll be 1/2. All right, so 2 to the -1 is 1/2. So that's going to be 1/2 here. So I'm going to get the point -1, 1/2. Now it's going to notice it's going to be right here. Okay, and then if x is -2, y equals 2 to the -2. So remember, to make the exponent positive, you're going to say this. You're going to say 1 over, and then you're going to say the base raised to the exponent to the positive power. So this means the same thing as this. So it's always going to be 1 over, and then when you rewrite this in the denominator, the exponent becomes positive. So that's going to be 1/4. So I get 1/4. So I get the point -2, 1/4. So notice what's happening. It's getting closer. See how it's looking? So it's getting closer and closer to something. And we're going to talk about what that something is in a little while. Okay, now let's let x be let's say -3. And notice I'm using integers here. I'm using integers, but remember you could use decimals. But remember, when you use decimals, you start getting decimals here. So just go ahead and use integers. Now, when x is -3, I get y equals 2 to the -3rd power, which is going to be 1 over 2 to the 3rd, which is 1/8. Now, you could have used your calculator. So, but basically, notice what's happening. So this is 1/8, and if I were to approximate this, and here's how you would use your calculator on this, by the way. So you would say, remember, trying to find 2 to the -3rd, you would say 2, and then remember you need to get this function here. You need to press this right here. All right, so you're going to say 2, and then just do this right here, to the -2nd power. Make sure you say negative, it's actually third I wanted to do. -3rd, press equal, and you get this decimal, positive 0.125. 0.125. So it's actually equal to 0.125. All right. Now, if x is -4, I get y equals 2 to the -4, and just use your calculator at that point. So 2 to the -4, so 2 raised right here to the -4 equal, and that's about 0.06, something like that. So I'm going to approximate that one, 0.06. But here's the idea. So notice that this is 0.25, this is 0.125, this is 0.06. Do you see that as I become more negative, as my x values become more negative, my y values are getting closer and closer, they're getting smaller and smaller. You see that? 0.25, 0.125, 0.06. So see how I was multiplying by 2 over here? 32 times 2, 64. 64 times 2 will be 128, and so on. As you go to the left, as you go on this side, you're actually dividing by 2. 1/2 divided by 2 is 1/4. 1/4 divided by 2 is 1/8. 1/8 divided by 2 is 1/16, and so on. Okay? So your y values are getting smaller and smaller and smaller. But here's the thing: do you see that no matter what x value I use, this is always going to be positive. we're always going to have a positive y value. Now remember, we're graphing this function here now, so keep in mind that it's this right here that we're graphing, but that we're going to have a positive number, and that this will never be, so in other words, it's not going to be negative, never negative, nor 0. Never negative nor 0. So it's getting closer and closer and closer. It's getting smaller. Okay, it's getting smaller. So it's getting closer and closer to 0, though. So it's getting closer and closer. Notice I'm not touching this x-axis because you're not going to have an x-intercept. So there's no x-intercept here. Okay, so remember, there's no x-intercept. And make sure you understand that. There's no x-intercept, which means that y is never 0. Remember, we're graphing this now. Keep that in mind. So y is never 0. So basically, and make sure you understand why y is never 0. So you're asking yourself, remember, this is y right here. So you're asking yourself, is this ever going to be 0? Well, remember, a positive number raised to any power, is always going to be positive. This is always going to be positive. So that's always going to be a positive number. So that's never going to be 0. Okay, so you don't have a y-intercept. So basically what's happening is that your graph on this side is getting closer and closer to the x-axis. Okay, so there's no x-intercept here. All right, now what we call this, so you see how it's getting closer and closer, because the y value is getting smaller. You see how it's getting closer and closer to the x-axis? That x-axis is called, and we use a dotted line to represent this word that I'm about to mention. So it's called the horizontal asymptote. Horizontal asymptote. ASYMPTOTE. So all exponential functions have a horizontal asymptote, and it's easy to find. You can see how to find it. Given an exponential function, you can easily determine what the horizontal asymptote is, and then go from there. All right. So in this case, your x-axis is your horizontal asymptote. All right. Now, whenever naming the horizontal asymptote, remember the horizontal asymptote is where your horizontal line. So remember, naming a horizontal line, you're going to say y equals. So in this case, it's going to be y equals 0. So for this right here, your horizontal asymptote is y equals 0. So the horizontal asymptote is the x-axis, or y equals 0. Okay, so you're just going to say y equals 0 though. So you're going to be asked for the equation. But if they don't ask for the equation, just say x-axis, because that's what it is. It's the x-axis. Okay, so that was that one. All right, now one other thing you can do from previous lessons is you can determine the domain. So what I want you to notice about this is this, the domain. So do you see that when I used x values, I could have chosen any x value, any number. I chose negative numbers, I chose 0, I chose positive numbers. So the domain is all real numbers. So the domain of an exponential function, so exponential functions, the domain is always going to be all real numbers. So the domain of an exponential function is all real numbers. Okay, so remember, as an interval, that's negative infinity to infinity. Now the range depends on this. It depends on where the horizontal asymptote is and whether the graph is above or below it. So in this case, the range of the graph is above the horizontal asymptote. So remember when we found the domain, we went from bottom up, and so notice I kind of start touching a graph. No, I said kinda, and there's a reason. So it looks like I'm touching a graph at the horizontal asymptote. And remember, the horizontal asymptote has y value y equals 0. But remember, it doesn't touch 0. It doesn't touch the horizontal asymptote. It says closer and closer and closer to it without touching it. So we're going to say from 0 to infinity. From 0 to infinity, that's going to be your range. From 0 to infinity. But instead of using brackets like you did before, it's just going to be parentheses because the y value is never 0. So the range for this particular problem here, the range, I'm going to go ahead and write it here, the range is from 0 to infinity. So for this graph right here, for this graph, the domain is all real numbers. In fact, it's going to be all real numbers always for every exponential function because you can use any number for x. But the range depends on where your horizontal asymptote is and whether the graph is above or below it. So in this case, you're going to, since the graph is above y equals 0, you're going to say from 0 to infinity with parentheses though. Okay, not bracket. Okay, now let's look at another one. So let's look at this one. So this is going to be number 2. We're going to graph f of x equal, let's see, 1/2 to the x. So 1/2 to the x. So what I want to also mention is this. So for this one right here, which was y equals 2 to the x, y equals 2 to the x, for this exponential function, notice as you go from left to right, your function is increasing. So remember you talked about increasing, decreasing constant. So this is always increasing. So this is an increasing function. So this is an increasing function. All right, now let's talk about this one. So we're going to do a t-table again. We'll use a t-table. And again, I'm going to let x be 0. Remember, we talked about the fact that all exponential functions have has a y-intercept since the domain is all real numbers. So remember, the domain is going to be all real numbers. I can use any number for x. So since I can use any number for x, I'm going to let x be 0. So I'm going to find the y-intercept. Okay, so if x is 0, I get y equal 1/2 to the 0. And so 1/2 to the 0, remember, is 1. So I'm plot the point 0, 1, which is here. If x is, let's say, 1, I'm going to get y equal 1/2 to the first power, which is 1/2. So 1/2 or 0, or I'm sorry, 0.5. 0.5, so I get this. So 1/2, which is about here. If x is 2, I get y equal 1/2 squared. And remember, 1/2 squared is 1/4, which is 0.25. 0.25. That's about here. And so notice what's happening on this side. So remember over here, your y values were getting larger and larger. Over here, they're getting smaller and smaller and smaller. See how it's looking? And the question is, as x gets, this is 0.25. So as x gets bigger, so let's say 3, I get y equal 1/2 cubed. And let's just use your calculator on that. So 1/2 cubed. So parentheses 1 divided by 2, that's your base. 1 divided by 2. And then raised to the third power, you get 0.125. Okay, if x is 4, so as x gets bigger and bigger and bigger, so if x is 4, I get y equal 1/2 to the 4th. 1/2 to the 4th. So let's see what that is. So in parentheses, put that in parentheses, 1 divided by 2 raised to the 4th. You get 0.06, about 0.06. I'll just do approximation here. If x is 5, you get y equal 1/2 to the 5th. So let's do an approximation on that. So 1/2 to the 5th. So in parentheses, 1 divided by 2 raised to the 5th. That's about 0.03. So remember, as you go this way, see how you're dividing by 2 each time because of the base is 1/2. So so 0.25 divided by 2 is this divided by 2 is this, and this divided by 2 is this, and so on. But notice, though, that as I get bigger and bigger and bigger, as x gets bigger and bigger and bigger, your y values are getting smaller. They're getting closer and closer to 0. Okay, so it's just kind of like the discussion we had in the previous problem. So basically what's happening is this. your y values, so if you plotted those points, your y values are getting closer and closer and closer to the x-axis. So the x-axis, again, is a horizontal asymptote. So your x-axis is a horizontal asymptote. So in this case, your horizontal asymptote is y equals 0, or the x-axis. Okay? Now let's look at what happens on this side. So notice that on this problem here, as you went from left to right, this was an increasing function. Your y values were increasing. Notice what's happening here. Your y values are decreasing. So this would be called a decreasing function. But something makes this increase and something makes this decrease. And so we're going to look at that in a little while. So let's look at some negative numbers now. So we looked at positive numbers. Now let's look at negative numbers. So if x is -1, I get y equals 1/2 to the -1. And remember, when you have a fraction, you learned that in the previous course, that when you have a fraction raised to the negative power, to make that power positive, you just take the reciprocal of the base. So this would be the reciprocal of 1/2 is 2, and then this becomes 2 to the first, which is 2. Even if you didn't know that, just use your calculator. So you'd say parentheses 1 divided by 2, close parentheses, raised to the -1 power, and notice you get 2. So I'm going to plot the point -1, 2. So when I plot the point -1, 2, I get this. Okay? Now let's look at -2. In this case, I get y equals 1/2 to the -2nd power. So again, I can use that idea I just used. So to make this exponent positive, I'm going to take the reciprocal of the base. So the reciprocal 1/2 is 2, and 2 squared is 4. And again, if you didn't know that, just use your calculator. So you're going to say parentheses 1 divided by 2, close parentheses, raised to the -2nd power, and notice you get 4. So I'm going to plot the point -2, 4, which is about here. And I'm going to keep on going for a little while. So if x is -3, I get y equals 1/2 to the -3rd power. And again, since the exponent is negative, I can take the reciprocal of the base to make it positive. So it'll be 2 cubed, which is 8. And again, if you didn't know that, use your calculator. So I'm going to get the point -3/8. And I want you to notice something. So as I get more negative here, so as x values go more negative on this side, my y values are getting bigger and bigger on that side. So the graph looks like this. So this is still called the graph of an exponential function. See how it looks? The graph of an exponential function looks like this. They're all going to look like this. All right, and remember, all exponential functions have a horizontal asymptote. So here's my horizontal asymptote, the x-axis. All right, and this we now know is a decreasing function, so my function is decreasing. So this is decreasing. Because as I go from left to right, remember, to determine whether it's decreasing or increasing, you always go from left to right. So as I go along my domain, which is all real numbers, my y values are getting smaller and smaller and smaller. All right. So remember, this is y equals 1/2 to the x. All right. Now here's how I can tell if your graph is, for the most part, there's something else that could change it, but for right now, I want you to notice this. What made this function increasing was the base. The base was greater than 1. Okay, so since the base is greater than 1, my y values are going to get bigger and bigger. So the function is increasing. All right, now here, notice the base is less than 1. The base is 1/2. So since the base is less than 1, your function will decrease. Okay? All right. Let's see what else. Okay, so the other thing I want to talk about here is the range. So notice the range for this one. The range, again, you always go from bottom up. So start with the horizontal asymptote. So the horizontal asymptote here is y equals 0. So your y value is 0. So you go from 0 to infinity. So any y value greater than 0 is you're gonna have a point in the graph. So, but remember, you can't use 0 because it never, the y value here is never going to be 0 because it doesn't have an x-intercept. So you're going to go from 0 to infinity. All right, let's look at another one. Let's look at number 3. Suppose in number 3 we had this. Number 3, let's suppose we had, let's see, we had 2 to the x minus 3. So let's say g of x equal 2 to the x minus 3. So a while ago we graphed 2 to the x, and you know what that looks like. So 2 to the x, see 2 to the x is this, y equal 2 to the x. But what does subtracting 3 do to this graph? That's the question. All right, let's do a t-table. Let's do a t-table. So if x, we use x and y, and again the domain of all exponential functions is all real numbers. So negative infinity to infinity, that's the domain. So I can use any number for x. So since I can use any number for x, that means that I'm going to have a y-intercept. So let x be 0. So if x is 0, that's going to be your y-intercept. If x is 0, I get y equal 2 to the 0 minus 3. 2 to the 0, remember, is 1. 1 minus 3 is a negative 2. So I'm going to plot the point 0, negative 2. So 0, negative 2. Okay, that's right here. Okay. If x is, let's say, 1, I get y equal 2 to the first power minus 3. So 2 to the first power is 2. 2 minus 3 is negative 1. So I'm going to plot the point 1, negative 1. So that's here. If x is 2, I get y equals 2 squared minus 3. So that's 4 minus 3, which is 1. So I plot the point 2, 1, which is here. If x is 3, I get y equal 2 cubed minus 3. Well, 2 cubed is 8. 8 minus 3 is 5. So 3, 5 is here. If x is 4, I get y equals 2 to the 4th minus 3. 2 to the 4th is 16. 16 minus 3 is 13, which is way beyond where I need to be because I want to stay within here. So notice though on this side it looks like this. Okay, just like before. You know, also you know that this is going to be increasing. So this will be increasing. So this will be an increasing function. So this will be an increasing function since the base is greater than 1. Since b is greater than 1. Okay. Now, so notice that on this side, your y values are rising rapidly. Now I want you to notice something. See, this was 2 to the x right here. And so notice that when x was 0, over here we have 1. Now we have, when x is 0, we get negative 2. Do you see what's happening? That I went from here and I went down 1, 2, 3. I went down 3 units. Over here, when x was 1, my y value was 2. When x is 1 now, my y value is negative 1. So I'm going from 2 to negative 1. Notice how many units? 1, 2, 3. So you may say, well, it looks like every point on this graph is being shifted down 3 units. And the answer is yes, that is true. And so that's why, I'll go ahead and, this was g of x. Oops, 2 to the x minus 3. So you see this right here? That number on the outside, that constant, shifts every, if you were to graph this right here, if you were to graph 2 to the x, this negative 3 shifts all the points down 3 units, even the horizontal asymptote. So right here, we saw the horizontal asymptote was the x-axis. So this negative 3 shifts it down 3 units. So now it's going to be instead of here, it's going to be 1, 2, 3. So your horizontal asymptote here, the horizontal asymptote is y equal negative 3. So you can easily determine the horizontal asymptote as whatever this number is on the outside, this number. So I'm going to go ahead and just graph the horizontal asymptote now. So your horizontal asymptote is y equal -3. Okay. So now you know, once you know this, you're done. You don't have to do, I keep getting these little gnats all over the place. You're done, because what happens on this side is that your graph gets closer and closer and closer to the horizontal asymptote. You don't have to plot any points like we did here. You're done with plotting points. So just plot a few and you kind of sketch your graph. Okay? All right, so notice how I did this. So you just plotted a few points. You know that on this side it rises rapidly, and you know that once you find your horizontal asymptote, you just draw the graph getting closer and closer to it. Now make sure you don't touch it, because it doesn't touch the horizontal asymptote, and it doesn't cross it. So it gets closer and closer to it. And make sure you draw your arrows, get close and close to this, and so forth. Okay? All right. Now a mistake people make is this. I'm just tell you right now. So if this were your horizontal asymptote right here, and you graph something that look like this, here's a mistake people make. They know it gets closer and closer to it, but then all of a sudden they make it look like this. It doesn't go back up now, so it'll make it look like that's wrong. That's not what the shape is. So it will make it look like it goes back up. So you got to make sure it goes closer and closer to it, and then you stop. Just draw an arrow and you're done. Don't make it look like it's going back up. Okay. And also this. Let me just say this. Also, if this was it right here, your horizontal asymptote, and this was your graph, don't make it look like it's a straight line. So don't draw a straight line like this, because it's not. Remember, your y values are getting closer, and they're getting smaller and smaller on this side. So if you draw a straight line like this, that means it's constant, and it's not. So it's got to look like it's decreasing. And just draw something just like this, and you stop. Don't make it. Don't do any more to where you're going to lose points. Okay. All right. Now let's talk about so we know the domain is all real numbers because it's a exponential function, but let's talk about the range here. The range. So remember, you start from your horizontal asymptote, and since the graph is above it, you're going to say from -3 all the way to infinity. But remember, your y value is never going to be -3. It gets closer and closer and closer to -3, but it won't be it. It will never be -3. So it'll be -3 to infinity. All right, now before we go on, let me just kind of explain something here. So I didn't do any negative. I didn't use any negative values for x, because I just wanted you to notice that you can quickly sketch these graphs just by finding a few points and then knowing that your graph goes towards the horizontal asymptote on this side. But if you did, for example, if x was, let's say, -2, you get y equals 2 to the -2 minus 3. Use your calculator. So 2 to the -2 minus 3. I just wanted you to see something. So 2 raised to the -2, subtract 3, you get -2.75. Okay. If x is, let's say, -5, I get y equal 2 to the -5th power minus 3. So 2 to the -5th power, 2 raised to the -5th power minus 3 equal, see, you get -2.97. So that's about -2.97. If x is, let's say, -8, I'm just using some larger numbers. I should say, in terms of absolute value, larger numbers. So y equals 2 to the -8 minus 3, because remember, -8 is not larger than -5. So 2 to -8, minus 3. See what's happening? You're getting closer and closer to -3. See these decimals on this side, if you look at them? -2.996. You're getting closer and closer. So as this becomes more negative, I should say, then these are getting closer and closer to -3. Okay? All right. Now, let's look at this. Just real quick, let's look at number 4. So number 4, let's suppose we wanted to graph g of x equal, let's say, 3 to the x minus 5. 3dx minus 5. So at this point, let's use everything we've learned. So domain, all real numbers. Why is the domain all real numbers? Because it's an exponential function. Since it's an exponential function. Okay. Now, right away we can find the horizontal asymptote. What's a horizontal asymptote? Is this number here. So you're going to say y equal. You must say y equal now, because remember the horizontal asymptote is a line. So you got to name this equation. You got to name this as a line. So you got to name the equation. You got to write the equation. So it's y equal negative 5. Just don't say negative 5. It's y equal negative 5. So right away I can draw the horizontal asymptote. Let's do that. So here's the horizontal asymptote right here. Okay, so your horizontal asymptote, use a dotted line. And let me go ahead and kind of enlarge it so you'll see it a little bit better. So you see right here, y equal negative 5. Okay? All right, now let's do a t-table now. You could actually tell me right away if this exponential function is increasing or decreasing. Since 3 is bigger than 1, since 3 is greater than 1, so since the base is greater than 1, g of x is increasing. So it's always increasing. It's always gonna look like this. Okay. All right. If x is 0, remember since the domain is all real numbers, I'm going to find the y-intercept. So if x is 0, I get y equal 3 to the 0 minus 5. 3 to 0 is 1. 1 minus 5 is a negative 4. So I'm plot the point 0, negative 4. Now notice I'm not going to do all these points like I did earlier. Okay, you now know what to do. You now know how to just plot a few points, and you know what the shape of the graph looks like, and you go from there. So 0, negative 4 is right here. All right, I know it's increasing, so I know it's got to do this. All right, so let's let x be 1. If x is 1, we have y equals 3 to the first minus 5. So that's 3 minus 5, which is a negative 2. So plot the point 1, negative 2. So that's this right here, 1, negative 2. Now you got to do a few more because you don't have enough to kind of do the shape yet. So you need about three or 4 points. So if x is 2, I get y equals 3 squared minus 5. So that's 9 minus 5, which is 4. So I get 2, 4, which is here. All right, so now I know that this kind of looks like this. So this side, oops, I could have drawn a little bit better. So this side looks like this. Okay, and on this side, you just make it get closer and closer to the horizontal asymptote, and you're done. So there's the graph of, now notice how quick this was. So that's the graph of g of x equal 3 squared, 3 to the x minus 5. And notice the horizontal asymptote is negative 5. The graph is in this case is above the horizontal asymptote. And then in one of the next lessons, we're gonna see that the graph is not always above the horizontal asymptote. It could always also be below. So we're gonna talk about what makes it below. What makes that reflection? Okay. All right. So the range. Let's talk about the range here real quick. The range will be from your horizontal asymptote, which is negative 5. But remember, it's the am I ever going to get a y value of negative 5? No, because the graph does not cross the y-axis. Does not cross the horizontal asymptote. So you get negative 5 to infinity. All right, and we saw that this was an increasing function. We found the horizontal asymptote. We found the domain, and that's about it. So that's how you graph these. And then real quick, I'm not going to graph this one, but I just want to mention it. Just a few details. If I have 1/3 to the x plus 2, all right, you want to graph this. Right away, you know what the horizontal asymptote is. What's the horizontal asymptote? I'm going to use HA. Horizontal asymptote is y equal this number. So y equal 2. The domain You know the domain. Domain's all real numbers. The all real numbers for all exponential functions. You can tell me whether it's increasing or decreasing. Since the base is less than 1, 1/3 is less than 1, it will be decreasing. So this will be a decreasing function since the base is less than 1. Remember, the base here is 1/3. You can tell me, without even graphing, you can tell me whether the the range. All right, so for us, everything has been above the horizontal asymptote. So in your mind, you have this. In your mind, this is what you have. You have your horizontal asymptote. You know that this is decreasing, so you know your graph's going to look like this, right? You know that's what it looks like. So your range will be from the horizontal asymptote all the way to infinity. So the horizontal asymptote here is y equal 2. So you can say parentheses 2 to infinity. Okay? Let's look at number 6. We'll do the same thing with this one without having a graph. G of x equal 7 to the x minus 4. All right, so again, you can tell me the horizontal asymptote. The horizontal asymptote is this number right here, so you can say y equal -4. The domain's all real numbers. Since it's a exponential function, is it increasing or decreasing? Well, remember, you look at the base. Since the base is greater than 1, it will be increasing. So increasing since the base is greater than 1. You could tell me the range. Okay, tell me the range. So we know that to determine range, if you need to, just kind of quickly sketch something that looks like this. So here's my horizontal asymptote, y equal -4. The graph's going to be above it. You know it's increasing, so you know it's going to do something like this, right? So it'll be from this horizontal asymptote, which has a y value -4, all the way to infinity. All right. Now, what I want to do now, real quick, is explain to you. Remember earlier we said that the base cannot equal 1. So let me kind of explain to you why that's true. So let's suppose the base was 1. Okay, so the base is 1. So why can't b equal 1? All right, well, suppose it was 1. Suppose we had this, f of x equal 1 to the x, right? Well, remember, 1 raised to any power, regardless of what this is, 1 raised to any power is always 1. So what we have here is that f of x equal 1, which means y equal 1. Well, remember, y equal 1, the graph is this. If you graph y equal 1, you get this horizontal line. So that's a graph of y equal 1. So that's a graph of f of x equal 1 to the x power. So notice, though, that this is not the graph of an exponential function. That's the graph of a linear function. So that's why y cannot equal 1, because if y was 1, it would no longer have this shape. It would not be the shape of an exponential function. All exponential functions have this shape right here. It's either increasing or it could be decreasing, but it has that shape. So if y was 1, it would no longer have that shape. In fact, it would no longer be an exponential function. It would be a linear function, because y equal 1 is linear. Now let's kind of talk about why the base can't be negative. So why can't the base be negative? Why can't the base be negative? Okay, so let's talk about that. Well, I want you to notice something. Suppose we let the base be, let's say, -2. All right. So let's see why the base cannot be negative. So the base is -2. You would say and the domain would be all real numbers. So if x is 0, you get -2 to the 0, which is 1. If x is 1, you get y equal -2 to the first power, which is -2. if x is 2, you get y equal negative 2 to the second power, which is positive 4. So notice though, as I graph this, I want you to notice something. You have 0, 1. See this right here? You have 1, negative 2 right here. You have 2, 4 right here. 2, 4. So you see there's no pattern to these things. So for example, if x is negative 2, let's say, negative 2, I get y equal negative 2 to the negative second power. And if you look at that on your calculator, parentheses negative 2 raised to the negative second power, you get 0.25. So if I plot the point negative 2, negative 2.25, this is what you have right here. So you see that there's no pattern that's going on. So so notice that as you go from, as my x values get more positive, some of my y values are positive, some are negative. Same thing here. If they become negative, some are going to be positive, some will be negative. All right, so there's no pattern to this. It's kind of like all over the place. So that's not the graph of an exponential function. So in order for they have, remember, all exponential functions have this graph, have a graph that looks like this. So in order for an exponential function to have this graph, the base has to be positive and it cannot be 1. All right, so that's why the base, that's why when we talked about exponential functions, the base must be positive and it cannot be 1, because in order to get this shape, that's what it must be. Okay, so that's going to take care of this lesson.